Here I have a sequence and I'm going to show you how to write the nth term for this sequence. My tip is to write the numbers down as you calculate them. So first of all, I'm going to look for my number to number, term to term rule. And as you can see, going up from 9 to 11, I'm adding 2. From 11 to 13, I'm adding 2. And from 13 to 15, also adding 2. So I'm going to use this 2 to go in front of my n. I'm going to finish off my nth term by imagining that this 9 isn't the first term. If I had a number before the 9, I would have to go back 2. 9 take away 2 will leave me at the number 7. Now 7 here, if I imagine these numbers being on a number line, this 7 is still after the 0. It's still a positive 7. So my nth term for this particular sequence is 2n plus 7. Here I have a different sequence, and again I'm going to come up with the nth term. I'm adding 3. Here I'm adding 3. I want to check just to make sure that it is the same rule all the way through my sequence. So I have 3n. Just as before, I'm imagining that I'm jumping back to another term before the 2. So I need to jump back 3 spaces. Now if I take 3 away from 2, I'm actually going to pass 0 and go into the negative part of my number line to -1. So I'm finishing off this term with a -1. 3n minus 1. And my third sequence, I'm going to work out the nth term. This time when I jump from 17 to 12, I'm actually going down. I'm subtracting 5. 12 to 7 is also a jump down, subtracting 5. And so my sequence continues. So this particular sequence is going to start off with a minus 5n. I still do the jumping back. If 17 wasn't the first number in my sequence, this time I'd have to add 5 to find it. It's got to be greater than 17. 17 add 5 is a positive 22. So I'm finishing off my nth term plus 22. Now this is the nth term, but I could, if I wish to, rearrange it so it starts off with the positive 22 and I take away 5n. Either way, it's correct. Here is an nth term, 3n plus 5. I'm going to work out the numbers in the sequence for this nth term. I'm going to start off by working out the first term. 3 times whatever value I give to n, and in the first term I'm giving it the value of 1 plus 5. 3 times 1 is 3 plus 5 is 8. My first term in this sequence is 8. I'm going to calculate the second term. 3 times whatever value I give to n, and in the second term n is 2 plus 5. 3 times 2 is 6 plus 5 is 11. My second term is 11. The third term, the value I'm giving to n is 3. So I have 3 times 3 plus 5. 3 times 3 is 9 plus 5 is 14. My third term is 14. I can continue to do this. 3 times the value 4 plus 5 is 17. 3 times the value of 5 plus 5 is 20. 3 times the value of 6 plus 5 is 23. And in my table, I'm only going up to the 7th term, so 3 times the value of 7 plus 5 is 26. In this way, I can work out any term value. I want to work out the 100th number in this sequence, so the 100th term. The value, therefore, I give to n in my nth term is 100. 3 times 100 plus 5. 3 times 100 is 300, plus 5 is 305. Therefore, my 100th term in this sequence is 305. Here I have an nth term of 3n plus 5, and I'm asked to find out whether 97 is a number in the sequence. I'm going to do that by setting up an equation. 3n plus 5 equals 97. Now I'm going to try and solve the equation. By subtracting 5, 3n equals 92. By dividing by 3, n equals, now if I do this as a side division sum, 92 divided by 3, 3's into 9 go 3, 3's into 2 don't go. I have a remainder. If I have a remainder, 97 is not a number in the sequence. My second example says, is 158 a number in the sequence? I'm going to try it again. 3n plus 5 this time equals 158. I'm going to solve the equation in the same way. First, by subtracting 5, 3n equals 153. Then dividing by 3, side sum, 153 divided by 3. 3's into 1 don't go, carry the 1. 3's into 15 go 5. 3's into 3 go 1 exactly. No remainder. N equals 51. Therefore, 158 is a number in my sequence. In fact, 158 is the 51st term in my sequence.